In a remarkable breakthrough that could transform how we think about aging, scientists at the University of Michigan have uncovered compelling evidence that a tiny, flatworm-like creature, one most of us have never heard of, might hold the biological key to reversing the aging process. Known as Schmidti mediterranea, or simply the planarian, this strange organism has long fascinated researchers for its seemingly magical ability to regenerate any part of its body, even its brain. But now, a deeper dive into its biology reveals something even more astounding. It doesn't just repair tissue, it appears to reverse age-related decline across its entire body. In essence, these creatures don't just heal, they get younger. What's most extraordinary is that this isn't just some superficial regeneration. The planarian doesn't simply grow a new limb or replace damaged cells. It restores lost functionality, improves fertility, rebuilds muscle, and regenerates neurons. The results, recently published in Nature Aging, offer the clearest evidence to date that full organism age reversal may not just be a sci-fi fantasy. It might be a biological reality, one that could eventually be replicated in humans. This discovery, led by Dr. Long Huagua and his team at Michigan Medicine, marks a significant leap forward in our understanding of how aging works at the cellular and genetic level. While researchers have long known about the regenerative prowess of planarians, this study takes it further by providing direct molecular data to show that these animals can essentially reset their biological clock. Unlike mammals, whose adult stem cells tend to decline with age, planarians retain their regenerative abilities throughout their lifespan, no matter how old they get. In some cases, cutting off an aged planarians had prompted the creature to regrow a new, youthful head, with fresh eyes, restored fertility, and renewed energy. And it doesn't stop there. Dr. Gua's team compared single-cell sequencing data from planarians with datasets from aging mice, rats, and humans. What they found was stunning. The age-related molecular signatures were shared across species. More strikingly, those same signatures that disappeared during planarian regeneration were also reduced in long-lived mice that had been subjected to interventions like calorie restriction. In other words, planarians may not be some strange outlier of evolution. Instead, they may be showing us a universal roadmap for how age-related deterioration can be halted and even reversed. This opens up thrilling possibilities. If we can decode the genetic and cellular machinery behind this whole body rejuvenation, we could one day apply similar techniques to human biology. Imagine being able to reverse signs of aging not just in skin or blood cells, but in the entire body. This could mean improved brain health, longer fertility, stronger muscles, and vastly extended health spans. It's not about living forever. It's about living well and living longer without the chronic decline we've come to accept as inevitable. It also shifts the narrative in aging science. Up to now, much of anti-aging research has focused on slowing the clock, slightly extending lifespan, improving quality of life, or reducing disease risk. But this study suggests something far more radical, that the clock can, under the right circumstances, be wound backward. For years, we've known that caloric restriction and other interventions could modestly slow aging. Now, for the first time, there's real evidence that regeneration and full physiological renewal can happen at scale, and perhaps even in higher organisms. Of course, we're still in the early days. The leap from planarian to human is vast, but the biology isn't as alien as we once thought. By pinpointing the exact genes and cellular programs that drive regeneration in these immortal worms, Dr. Gua's lab is paving the way for breakthroughs in regenerative medicine and age reversal therapies. And they're doing it not with science fiction, but with hard data, peer-reviewed research, and a clear biological mechanism that could one day be mirrored in our own cells. What this study ultimately shows is a shift in mindset. Aging has always been seen as an inevitable decline, a gradual fading of function that no creature, not even humans, can escape. But nature, as it often does, defies our expectations. The planarian reminds us that aging doesn't have to be a one-way street. In some species, it isn't, and in time, maybe it won't be for us either. This is more than an intriguing biological curiosity. It's a glimpse into a future where age is not a sentence, but a state, one that, perhaps, can be reversed.